So this question says if px squared plus 4x plus 1 is a perfect square and p is greater than 0, find the value of p. So the first thing we're going to want to do is think about what a perfect square is. So a perfect square is a binomial. So it's got two terms, ax plus b, where a can be any number, it can be any number, plus b all squared. So that's what the definition of a perfect square is. And so if we just expand that out, we're going to get, if we just look at the left-hand side here, if we expand that out, ax plus b multiplied by ax plus b, expanding it out using FOIL, every term multiplied by every other term, we're going to get ax times ax gives us a squared x squared, ax times b plus ax times b is 2abx plus b squared. Okay, and since this thing is a perfect square, we know that these polynomials are identical. So we can say that this thing, when it's expanded out, is equal to px squared plus 4x plus 1. So what we can say straight away is that this value at the end, b, is clearly equal. So this b squared value here is clearly equal to this 1 here. Just by looking at it, because that's the last term. It doesn't have any x's in it. This one doesn't have an x in it. And this is the only term on the left-hand side that doesn't have an x in it. So this b squared equals 1. And then if you solve for that, you take the square root of both sides. You take plus or minus 1. And so we've got firstly b equals plus or minus 1. And then what we can say is, all right, this 4 here is equal to this 2ab. Again, just by looking at it, the coefficient of x is 4, and the coefficient of x here is 2ab. So what we have is a situation where 2ab equals 4, but we know that b is, let's say, positive 1 first. So we're going to get 2a times 1 equals 4. So 2a equals 4, in which case, therefore, a equals 2. Now, we can obviously take the negative portion of that because we said b could be plus or minus 1. So we can say 2ab equals 4. In which case 2a multiplied by negative 1 equals 4, and therefore a equals negative 2. But you'll see in a moment why that doesn't matter. Because if we now look, we can see that the coefficient of x squared on the right-hand side is p, and the coefficient of x squared on the left-hand side is a squared. So we know that a squared equals p. Again, the coefficients must be equal if these polynomials are identical. And we know from these ones that a equals 2 or negative 2. Now, it doesn't matter which one we pick, because when we square it, it's going to become positive. So let's say we pick a equals positive 2. We square that, we say a squared equals p, so we get 2 squared equals p, therefore p equals 4. So we've answered the question p is equal to positive 4, and what we can do is we can actually substitute that in for p now. So let's see what happens if we do that. This p value is 4, so it's going to be 4x squared plus 4x plus 1. And let's see if that's a perfect square. So some of the skills we've learned later in the unit, we'll be able to tell if this is a perfect square. So we're going to factorize this. We're going to say what multiplies to give 4 times 1 and adds to give 4. Okay, and hopefully you're thinking 2 and 2. So, we can factorize by grouping. We're going to break that 4x term into 4x squared plus 2x plus 2x. So we're breaking that 4x into 2x plus 2x, and then obviously plus 1 at the end. And then we factorize by grouping. So we look at this first part, 4x squared plus 2x. If we take a 2x out the front as a factor, we'll be left with 2x plus 1, and we've got a 2x plus 1 over here. And then we take that 2x plus 1 out as a factor altogether. So this 2x plus 1 comes out the front, and we're left with 2x plus the imaginary 1 that's multiplied there. So you can see our final result is 2x plus 1 all squared. Hopefully that clarifies how you can make this a perfect square. You need to equate coefficients.